Permutation with cases is and you had one actually in your first assignment there, is when you can't count something all at once, and you have to break it up into smaller things to count. So, for example, when you did question 9 from Permutations 1, in part A, they said, the president is female, the secretary is male. And you found out that there was 6 ways that that could happen. In part B, the president's male and the secretary is female. And you found out that there was 6 ways for that to happen. Then part C says, well, how many ways could you do it if you had to make sure that the president and the secretary were opposite sex, no matter which was first or which was second? And there's no good way to count that directly, but since you knew that there was 6 ways in A and 6 ways in B, you just needed to add them up to say, well, then there would be 12 ways to get part C. So what we're going to find with permutations with cases, it's exactly that. Sometimes you can't count it all at once, but if you break it up into separate cases and count those cases separately, add them up, you'll get your total. So this is an example of a cases question because this one says, at most 3 different digits. How many numbers of at most 3 different digits can be formed using the digits 0 to 9? I'm going to add here, we're going to deal with this as if no repetition. Sometimes a textbook or workbook will say if they're giving you a list of digits, that means you can't use more than what you have been given. So you'd only be able to use the number 9 once, the number 8 once. Why is this a case question? Well, if it's at most 3 different digits, you could have 3 digits, 2 digits, or 1 digit. And you're going to count those separately. So what we can do, and what we do in case questions, is we always identify what we're counting first as case 1. Case 1, I will count 3-digit numbers. Well, there is a restriction. The first digit is not 0. Otherwise, it's not a 3-digit number. There would be 9 choices there. Then you've used up one number, but you could put a number back in, so there'd be 9 choices there. And then finally, 8 choices in the end for 648. And that's counting all the 3-digit numbers. But the question said at most 3 different digits, so it could be case 2. 2-digit numbers. Again, if it's a 2-digit number, there is a restriction that the first digit is not a 0, giving you 9 choices. And then, if you put in a different number, now 0 can get put back in, but one number is missing. 9 choices left for 81. And case 3, 3-digit numbers. Is 0 a number that has 1 digit? I think it is. So then you would have 10 choices there. The total, adding them all up, would be 739. Yes. Yes, I do mean 1 digit. I don't know what my brain is. I saw that 3 and I probably just wrote another 2. Thank you. Yeah, case 3 is just a 1-digit number. So there are questions that we can't deal with directly. We call those ones cases questions. Very typical cases questions are questions that have restrictions on more than one thing. So this question here has 2 restrictions. And if in those 2 restrictions they overlap, it's impossible to count all at once. So here we have an example we're using the numbers 1, 2, 3, 4, and 5. We need a number bigger than 300 and even. So there would be a restriction on the first digit that if you want it to be bigger than 300, your only options are 3, 4, and 5. 300s, 400s, 500s. And if it's even, there's a restriction on the last digit that the last digit has to be either a 2 or a 4. So if we tried to do this all at once, we would draw our spaces for 3 decisions. We would say there's a restriction here, 2 or 4. There's a restriction here, 3, 4, or 5. Don't write this down because this is going to not work because we're going to try to count it all at once. And you remember when we learned about restrictions, you had to deal with the restriction first. But now we have 2 restrictions. Maybe we do this restriction first. If I do this restriction first, there would be 3 choices. Right? Then I'm going to go to this restriction. What number would I put in here? Well, it looks like there's 2 choices, unless I used up the 4. Then there's only 1 choice. But I don't know which number I chose. I just said there's 3 choices, but we don't know which one you chose. And now we have a problem that sometimes this is 2, sometimes this is 1, but I don't know which number to write. And the mathematics falls apart. So what we do to solve these ones where there's 2 restrictions and something overlaps, there's the problem, is that 4, right? We count it separately. And we count it separately with cases. We would say, well, I know that it has to either end or in a 2 or a 4. Why don't I start with all the ones that end in 4? So now I have 3 spaces, but I'm saying I know for sure that the last digit is a 4. I still have another restriction, but when I go to my second restriction, what are my options for the first number? If the last one is a 4, you're only counting numbers in the 300s and the 500s, which would tell me that there's only 2 choices for that decision. How many choices do we have for the space that doesn't matter? 3. Why is it 3? Because we had 5 numbers, we used up the 4, and then we either used up the 3 or the 5, but no matter which one you use up, you still have 3 choices left. Which would tell us that there are 6 numbers that end in a 4. Case 2, what haven't we counted? We haven't counted the ones that end with a 2. So now, we say, okay, well, then if we count the ones that end with a 2, now I'm making 1 choice for that one, but then my first digit could be the 3, the 4, or the 5, giving me 3 choices. And if I've used up 2 numbers, 3 choices left. Would give me 15 in total. 9 with case 2, 6 with case 1. So if you have restrictions that overlap, you're going to have to count this with cases. And you choose one of your restrictions and break it up. I happen to choose the last restriction and broke it up. You could have chosen the first restriction and done this in 3 cases. Start with a 3, start with a 4, start with a 5. You would have got the exact same answer. You could have done the first restriction and said, first I want to start with 4. Then I want to start with a 3 or a 5. Do you want to see that other method? Because I'll just do it quickly. Case 1, if I started with a 4, this has to be a 4, 1 choice. Then this would have to be, to make it even, the 2, 1 choice, which would only give me 3 of those those numbers. Case 2, I could start with, what haven't I counted? A 3, 4, a 5. 3 or a 5, 2 choices. That would let me end with a 2 or a 4. 2 choices, 3 here. 12 in total, add them up, I get 15, same as before. So which restriction you decide to break up doesn't matter as long as you're explaining it in your instructions. Like case 1 was this, case 2 is this. Generally, as a making your life as easy as possible, if you have a case that only has 2 options, that's usually a good case to break up, because it's either this one or this one. You only have 2 cases, right? If you broke up the first case, you could have made 3 cases, which wouldn't be wrong. You just might write more. It would take a little bit longer. So this is one typical kind of case question where they ask you and give you more than one restriction, and you have to figure that out. Greater than 232. So we're still using 1 to 5, right? You're going to just have to read part A again. Make sure. Yes. It just using 1 to 5. They don't have to be even. No repetition. Greater than 232. So this is the second major type of cases question, where they give you a set of numbers and say, can you count how many numbers are greater than that? 3-digit numbers greater than 232. Why is this cases? Well, there could be numbers in the 300s, the 400s, the 500s, but there's also some numbers in the 200s, right? Like all the 240s and 250s are fine, but not all the 230s, and definitely no 210s or 200s. So we have a little bit of a problem with trying to count. If we tried to count it all at once, our first number can be 2 to 5, 4 choices, but then you don't know what to put next. Because if you pick the 2, you have restrictions. But if you pick the 4, you wouldn't have restrictions. Because all the 400s are going to be bigger. All the 500s are going to be bigger. But not all the 200s. So what I do with these greater than ones, since doing it all at once will not work, is I always start off with the case that makes no more restrictions. Like in other words, if I started with a 3, 4, or 5, it doesn't matter what the other numbers are. All my numbers in the 300s, all my numbers in the 400s, all my numbers in the 500s are guaranteed to be bigger than 232, no matter what numbers I use after that. So if I start with 3, 4, or 5, so my first decision, I make a 3, 4, 5, 3 choices. That means I'm guaranteed to be bigger. No restrictions on this one, no restrictions on this one. How many numbers do you have left for the second decision? 4. Why? Because you just chose, you had 5 numbers, you just chose one of them. You still have, right? If I chose the 5, the 3 and the 4 are still possibilities that go back into the mix. Now, after I've chosen that second digit, does it make sense that there would be only 3 choices for my third one? Because now you've used up 2 numbers. You don't know which 2, but you would still have 3 left. 9 times 4, 36 in total. Case 2. What haven't we counted were the numbers in the 200s. So you start with a 2. Then, so my first base for sure is going to be a 2. One choice. But then there's some choices to do in the second one. I can't just say 3, 4, or 5 because then I won't know what to put for my last number because the 3 has further restrictions. But can you see that the 4 or 5 wouldn't have further restrictions? So in the same idea here, I'm always starting with something that doesn't have restrictions. Then I go to the one that has restrictions, but then for the second one, if the second one is a 4 or a 5, two choices, that would count all my numbers in the 240s and 250s, guaranteed to be bigger than 232, which would leave me with no restrictions on the last one. There would be 3 choices left because I've used up the 2 and either the 4 or the 5, but I'd still have 3 numbers left. Multiply those out 6 ways. Then you ask yourself, what haven't I counted? I haven't counted any numbers in the 230s. So case 3, start with a 2, then a 3. So again, 2, 1 choice. 3, 1 choice. Now what's available? There's still restrictions on the last one, right? Because it has to be bigger than 232. We can't use 1. What numbers are possible? So whenever there's a restriction, and there's going to be a restriction on this, write out the possibilities underneath. Can you see that a 4 is possible? 5 is possible. Why isn't 3 possible? Because it's already used up. Or you might be tempted to say, oh, there's 3 choices here. It could be 3, 4, or 5. But the 3 has been used up. So there's only 2 choices here. 1 times 1 times 2 is 2. Add up 36 plus 6 plus 2. And there'll be 44 ways in total. You. Okay. That is our cases note. We are going to, combinations is the next idea. We're going to go back to the textbook and learn that. But right now, you now have permutations 2, 3, and 4 that are a mixture of all the strategies we have learned so far. If we summarize what we have learned so far, in permutations, right? We have learned the fundamental counting principle, which is basically the spaces technique. You make a space for each decision. Number of choices go into each space. That's the fundamental counting principle. Within that fundamental counting principle, we have sometimes added restrictions. If there was a restriction, like you want to build numbers, but they have to be even, you always deal with those first. So if you have a restriction, then you deal with those first. Okay? We also had identical object questions, like the word Mississippi has S repeated 4 times, I repeated 4 times. You would count it like a normal spaces question, if there was 8 letters, 8 factorial, but whatever is identical gets divided out. So if you had an 8-letter word that had 3 M's, then you would have to divide by 3 factorial because of that identical object. After identical object, we looked at questions when you put things in groups. Certain people want to sit together. Certain things need to stay together when you're organizing them. So grouping questions, you did the number of groups first, factorial, then you looked within each group how many there were. And finally, today we found out that some things can't be counted all at once. Those need to be counted in cases. So these are your main strategies and frameworks in which you work with, and then each of the questions on our reviews deal with those. I guess we did do a little bit of algebra stuff, right? We learned how factorials worked, and you always simplify the bigger ones. We had equations that use the NPR formula, so those will come up as well. But as far as word problems go, you have to decide, where does the word problem fit within these strategies? Is it just a spaces question? If it's a spaces question, what are my decisions? What amount of choices do I have for each of those decisions? Do I have a restriction? If I have a restriction, I need to deal with that first. Do I have identical objects? Right? And now we have these. There are going to be some questions that have identical objects and grouping, or grouping questions with cases. Oh, another thing that we looked at was the not strategy. Sometimes it's easier to count what shouldn't happen rather than what should happen, and you can subtract that from the total. So the not strategy was count them all, subtract the bad ones. I think there's one question in there that has grouping, not strategy, restrictions, all built into one. So they can get complicated. So we have more than almost 40 minutes. You've got those next worksheets to work on, to get started on.